Testing, testing. Okay, camera 1, camera 2. Yep, that's all good. Let's get that set to reject low frequency. Yeah, that's good. Camera 3. That's the one. That's all good. Camera 4. There's a bit more of a lag on this one than there used to be. Look, you can see it. Oh no, they're probably about the same. And then camera 5, screen. Cool. We are good to go. Yo, Jason, how's it going, man? Jason Nora, how's it going? Thanks for jumping on. You're the first one in the stream. Nice. What's up, Moto Skater? Hopefully we're going to learn something tonight. Yes, absolutely. Hopefully we're going to learn something tonight. How's it going, Daniel? Oh man, this is, these kickers use the American sized flipping Allen keys, don't they? They're like in between what we have over here. I suffered the same thing with the JBL. Jesse, how's it going? Yo! Okay, now it's a stream. Jesse's here, now it's a stream. What's popping, guys? What's popping, guys? Finally a live stream. Yeah, it's been a hot minute, hasn't it? Been working on a few other projects in the meantime. What's up, Disastrous? What's up, John? What's up, Jason? Another Jason. The double Jason. Jayception. Evening, Joseph. Yo! How's it going, my man? Still haven't got the parts for that Terramps you gave me. But that's my own fault, because Terramps did ask me for a list of parts that I would need, and I haven't given it to them yet, because I'm just accumulating a few bits. Imperial Allen keys. Yeah. So for those Imperial Allen keys, I just use like a star security bolt type thing that fits nicely in there. Problem with that is you have to be really careful not to apply too much torque, because you completely round off your bits. Love the ZR amps. Not had a huge amount of experience with them myself personally, so let's see what we've got going on inside this one. Let's take this back off. I don't actually remember what's up with any of these, so I've got a couple of kickers. I got this one, and there's a what model is that one? It's an FX 2000.1, I think, or EX 2000.1, I think, is the other kicker that I've got that we could look at this evening as well. Hey Matthew, how's it going? So if anyone's curious, so in the live chat right now we've got Matthew for McKeever. Wait, where is it? Yeah, Matthew for McKeever, which is the guy with the long ass hair with the hair trick in my most recent video. Not much happening, doing good. Sometimes it's alright when there's not much happening, isn't there? Woo! Look at this bad boy. That is one strong transformer for what is essentially going to be. Is this a? I don't even know. Is this a 2-channel amplifier? Is it? Oh no, it's a sub amp. It's a Class AB sub amp. You know what? This would be so perfect for the next video idea that I've got. I'll have to ask the customer whether after repair I can just like hold on to this for a week or so and include this in one of my new videos. Awesome. Class AB sub amp. Old school ting. Old school ting we have right here. So the fact we know this is a Class AB is because we have no Class D output filter inductor. You might get this confused with it, but that is actually another filter for the rails. And we know that it's Class AB because we have emitter resistors along all the output devices. So yeah, cool little tang. Pretty big Class AB. Nice squishy pads. Yeah, these can be a pain to get off if you haven't got the right tool, but luckily I have. Really interesting way of doing the low pass filters. So these amps have a little slide-in crossover. They call it crossover. Subwoofer crossover module, so you can't actually, by the looks of it, I don't think you can set a frequency for the low pass filter. You just have this module and it has a switch on it that has bypass, low pass or high pass, and the manual will most likely state what those frequencies are for those filters, and it just slots into this little sort of header thing there. Pretty cool. Nice little cool design. You got a couple of relays on the outputs there. Looks like the relays actually might be not only taking the, unless this is a full bridge class AB, like it's kind of 2 channels. Maybe this is a 2-channel thing, but set up as a mono. Oh wow, a lot of board flex over here. Holy bananas. That is a butt-ton, a truckload of board flex over here. That is not the best thing, because there is going to be inherent stress from this board flex on these pins, especially over here right by where that's flexing, and also this transistor here, which is probably doing auxiliary voltages. I'll definitely double check all of those parts, because that is quite a bit of board flex over there. Bit of board flex over here as well. But otherwise, not a bad thing. Not the best seating down of the transformer. Lots of loose winds here. Definitely could rub and short out the transformer, giving enough vibration. We have, yes, what looks like 2 separate channels. So if this is a mono, like I say, I haven't done much work with this, but if this is set up as a mono, oh no, it is set up as a 2-channel. Left plus minus and right plus minus, and then you can bridge it. Okay, cool. So it's a 2-channel. Awesome. Yes, it's a 2-channel and an actual 2-channel, not a 2-channel that's being used as a mono, because we have 2 separate bias adjustment potentiometers here for each channel, which I imagine on the sub amp will probably be set relatively low. We've got a nice header here on the board that's labeled, that will give us a nice easy access point to test all of the auxiliary voltages. So you can see we've got plus minus 45 volts, which is likely to be the rail. Plus minus 15 volts, our auxiliary supply for the op amps in the preamp section, and so on. U5 to 6, 2 to 6. That's going to be, U is usually a chip of some kind, integrated circuit of some kind, so maybe that's some supply voltages to a specific chip that's different to the plus minus 15, perhaps, or not sure yet. Then we've got L plus and R minus, and the reason that we have that is because the right hand channel's signal will be flipped 180 degrees out of phase, allowing you to bridge this amplifier without needing to flick a switch first. So the right hand channel's output, it will actually be flipped 180 degrees at all times, and it is given to the right hand negative channel terminal, so that when you hook up 2 speakers, normally without bridging it, both speakers move in phase with each other, but when you bridge it, you can just put the sub wires between the left positive terminal and the right negative terminal, which will then give you the 180 flipped bridge application, ground, and CHAS, probably chassis ground there as well. So nice little header for in-factory testing, probably before these went out, QA, that kind of thing. Alright, zoom back out. So let's see, why is this amp in the workshop today? Unfortunately, as I was preparing for this stream, I ripped off the negative probe to my multimeter. So I just very quickly shoved a bit of metal on the end there just to do this stream with. So I need a new set of probes for the old multimeter. Got those on order. But for now, we'll just have to make do with what we've got here. So, do we have any shorted output transistors? Let's test that first. So, we have 34 ohms between legs 1 and 3 of the output transistors. Now, if you're not so experienced with Class AB, especially if you repair a lot of Class D, you might think, oh hey, this is a problem, this is a fault, this is not good, this must be dead. Well, actually no. In a lot of Class ABs, you will actually have a low resistance like this between legs 1 and 3. The thing that's key about Class ABs is that if this low resistance is the same across all of the output devices, especially between channels, then this is totally normal. Yep, there we go. The thing that we're looking for is a short between legs 1 and 2 or legs 2 and 3. If there's any shorts there, then we know we definitely have a problem. So looks like we don't have any shorts between 2 and 3, or 1 and 2 on this channel. Aha! But we do have a short between 1 and 2 and 2 and 3 on this channel. So there is a key, really good example there of a Class AB failure and how to detect it. And you can also see here that when we measure between 1 and 3, instead of getting the 34 ohms, we've got like 2. So yes, output section failure, likely the amplifier was driven too hard, speaker terminals were shorted out, that kind of thing. Okay, so it looks like we've only got dead transistors along this bank here. So for each channel, this is a Class AB amplifier, so we'll have NPN and PNP transistors for each channel. So let's take this cover off, let's take this plate off and have a look, see what ones have died, whether it's the NPNs or whether it's the PNPs. Oh no, you know what, I don't think I'm going to have a socket set for this size of bolt. I might have to go and get my socket set itself. So in here, usually these things are that just so happen to be the same size as the screwdriver bit things that go into your handle, but it seems that this one is a bit bigger. Might have to go and get my socket set. What do I have? One in here perhaps. Let's have a quick read of some live chat before we do that. Sometimes I consider getting rid of it because at times it's annoying, honestly. Well, it does mean that you can do some pretty sweet hair tricks. And I do miss having hair, and I used to have long hair, not that long. It was maybe a bit long though. So enjoy it while you have it, I think. Man, thanks to Seth for the 5. How's it going, man? Good to see you on the stream here. I had 6 of those on 6 JL Audio W7s. Damn, that's a clean system. Wow, 6 of these Class AB, nice old school Class AB amps on 6 W7s. Holy hell, I'm pretty sure I still have one laying around here and my mother's house somewhere. Heck, nice. Should be 8mm. Okay, I will. Yeah, I think the socket set is in the van because I've obviously been doing some testing stuff in the van, so I'll have to BRB and get that out of the van. Are Hyphonics worth repairing? Generally, yeah. I mean, they're not like super amazing or anything like that, but most of the Hyphonics are okay, will sound fine on subwoofer application. Most of them, well, you know, sort of 1600 watts RMS and above, yeah, it's worth repairing. Pretty easy to repair as well, so yeah. Hello from Seattle. Oh, I tried to repair an amp too, an old Crossfire VR4000D with blown power supply transistors. Heck, well, good luck with that. Remember, change your gate resistors and your drivers. Do you ever deal with amplifiers with some of the newer style Class D, like UCD Hypex Purify? Brian, I can't say that I have, although I might have seen the circuits that these use, similar circuit designs, but I'm not familiar with any of these 3 names here, so not sure. What is an emitter resistor? It is a resistor that is in line with the emitter of the transistor. That's the best way of putting that. Those are the best pants with the inserts that they have. With the bridgeability, you can hook them up in different ways. Amps. Are Kicker designed amplifiers a good design? It's like, it's going to vary so much. Like, I can't say across the board. One thing that I do like though is that Kicker have designed a lot of their own amplifiers complete from scratch, which I respect much more than a lot of brands just going to a build house and having an off-the-shelf standardized board layout from the factory made with their logo on it, maybe a few modifications. So yeah, I respect Kicker. Design a lot of their own stuff. Seem like really cool guys. Definitely have some guys working from them that know their stuff. So yeah, I'm sure that lots of the amps are a pretty good design. This one here, without testing the electrical characteristics of this amplifier yet, I couldn't tell you whether it's a good design per se or not, but we do have adjustable bias, so it's not some horrendously unbiased fixed bias thing that you would see a lot of. In the cheaper amplifiers, we've got relays on both the channels to isolate and prevent turn-on pop, which isn't usually an inherent thing with Class AB, but that will protect the speakers or subwoofer if there is an output section failure, which in this case there is. So these relays actually may have protected whatever sub or speakers were connected to this amplifier when it did fail. So that's pretty cool that you've got that. Other design things, it's nice and symmetrical. You've got the biasing transistors clamped directly to the heatsink there, which is always nice to see. You can't always rely on that. But yeah, without sort of doing electrical tests, can't really comment too much on the design of this apart from just what I can see visually here. Build quality could definitely be better on this one. Okay, I'm going to BRB and get my socket set, not in the loft, in van. So I can go and get my socket set to get these clamps off. Getting socket set. BRB getting sock. Make that a bit smaller. Yeah, back in a sec, guys. Okay, how's it going, guys? Just grab my socket set. Let's get this back on. So we think 8mm for these. 8mm. That looks about right. Is that actually the 8mm? Yeah, it is. Cool, cool. Have that and the extender. Dear friend, greetings from the city of Omsk, Russia. How's it going, Vlad? Thanks for jumping on the stream. Those kickers put out a lot more than 600 watts. I was running them at 3 ohms bridged. They did get hot, but what can you expect from Class AB? Well, yeah, that is one of the issues with AB, is that they do run super, super hot, especially when you're driving them hard. So yeah, this is an 8mm, so that's pretty cool. Brian says, I think you'd find the performance of these Hypex N-Core and Purified chips to blow away any old style Class D. They are simply next level. I can get rid of this sign now. Direct Class A competition in terms of quality. That's really cool to hear. So I would love to definitely experiment and have a listen to one of those. Actually, you know what I do have? I don't know what style of Class D it uses, but I do have a very expensive, although I think it's a bit old now, it's a Chapter Audio Chapter 2 amplifier, which is like a dual monoblock, really high-end home hi-fi amplifier. I think it costs like 6 or 8 grand new, and it's Class D, but I don't know what type. I don't know if it's this type that you're telling me about here, but it's supposed to be rivaling Class A sound, supposedly, according to the marketing material. But I'm actually planning a video which puts Class D and Class AB head to head for subwoofer application for now. I might do full range in the future, but I think a fun thing is to do subwoofer application comparisons, because I think there's a lot of people that are really, really hard set on how different amplifiers sound on subwoofer application. I think it's pretty standardized. Most people will agree that Class AB sounds a lot nicer than a lot of Class D does on full range. That makes a lot of sense. And yeah, but for subwoofer application, I want to see if that still holds true. So the next video will be Class D versus Class AB on a subwoofer application. Need to figure out the logistics of that test. But if I can grab one of these amplifiers with this new Class D tech that Brian is talking about, if there is a car manufacturer that's doing them, that would be pretty cool. Hello Jay, how's it going? Thanks for jumping on the stream. Can you repair old 90s RTO amps? I have a complete set which has taken me years to find, but one of them, the gain knob, is stuck solid. It works fine, but I can't turn it. Yeah, I mean, that's pretty simple. That's just going to be a new potentiometer or something. So yeah, there's no inherent circuit knowledge required to do that repair, so there's no reason I couldn't do that. So what we're going to do for this one is, this one's coming all the way out the case. We could probably do a top board repair on this one, but the reason I don't want to do that is because we do have some board flex over here, and I want to absolutely double check all of the component legs on this side and the other side to make sure that there's no metal fatigue. Oh man, Brian, that reminds me, I used to work for a shop called Comet, which over here in the UK is an electrical kind of store. Sold TVs, Blu-ray players, fridge freezers, washing machines, vacuum cleaners, laptops, that kind of thing, cameras. So it was all commission based, my job. So I got commission on certain items. Well, I got commission on all items, but some items had a lot more commission on than others. We used to sell Monster cables, Monster branded cables. And we had a whole wall which was dedicated to Monster HDMI cables, and there were, as you know if you've ever seen Monster HDMI cables, lots of different classes of cable that Monster sold. You had like bronze, silver, gold, platinum or something like that. Each of them had different marketing terms on the front saying like what it was capable of, HD, 3D, UHD, however many hertz, whatever for each HDMI cable. And these HDMI cables were extortionately expensive. Brian here says 50 bucks. Try 90 pounds, which is at the time was like 130, 140 bucks. Sad as it is, I was quite young and I was commission driven. A guy came in to buy a Blu-ray player. The Blu-ray player that he bought, that he wanted, was £60. It was a Sony Blu-ray player. £60 for a Blu-ray player. And he was asking about HDMI cables. My salesman kicked in. I was like, well, you know, if you're buying this nice Blu-ray player, it has the ability to produce really nice picture, really low compression, high bitrate video, audio, etc. like that. I said, well, you're going to want a good cable that can actually make the most of that, and that can actually transmit that nice quality and not hinder the abilities of this Blu-ray player getting to the TV. So I took him over to the Monster HDMI cables wall, and he left the shop with a £90 HDMI cable to go with his £60 Blu-ray player. Felt absolutely terrible, but unfortunately that was the job that I had. That was my job. And it's pleased me. Well, I'll say it pleased me that Comet went bust while I was working there actually. But Monster Cable is still a thing. I don't know if their business practices are still as sketchy as they used to be, but okay, cool. So that's all of these bolts undone now in this thing. Now there is some foam which I don't want to break, so I'm just going to pry this up gently and just kind of let it unstick itself from these transistors. There we go. There's one plate. Pop that down the back here. Another plate. Let's just not do this too quickly because I don't want to... there's been some soldering attempt in here. I just noticed that there's some black marks on the foam over here, and some janky looking solder over here. I suspect that that is as a result of vibration damage actually, and that someone has already attempted to repair a snapped component leg. What did I tell you? When I first looked at this thing I said, hey, vibration damage. Seems like that has actually occurred at some point in this amplifier's life. So let's remove... Actually, no, I could probably leave this side. I should leave this side. No, I'll take this side off. I'll take both sides off. I just don't want to tear it, that's all. I have an Earthquake 480 UHC amp. Have you ever heard or worked on them? No, I don't think I have. Earthquake isn't really very big over here in the UK, so I tend to only get experience with working on amplifiers that we have over here. So no, I think that would be a new one for me. Come on. I don't want to rip you. Coming away slowly. So we have our first sight at what transistors this is using. TIP. Come on. Okay. TIP 35C and 36C will be the complementary. Might heat it up. That's not a bad idea actually. Good shout. Good call on that. If I can find my heat gun, of course. What do I do with my heat gun? Perhaps I'll just use the small one. Ew, why does it have those strips? And can they stretch or rot over time? They get dry over time, but these strips will be to allow, so obviously these transistors, generally most of their heat is dissipated from the back of them. That's why the back of them is clamped to the heatsink. But they also are able to dissipate some heat out the front of the package. And so these pads are to squish down onto the transistors so that the long ass clamps not only provide an equal mounting pressure to all of these transistors in one go, but this will also help to transfer heat from the transistors to the to this big metal bar, which will have a bit of thermal mass, so that will actually help with cooling a little bit. It's tempting to give up on that side. The side that we need to get off is this side, because this side is the one that has the dead transistors. I might actually cut it between each one. Let's see if we can heat it up a little bit. If you have two Class D that did identical peak power on a dyno, would they do the same power throughout all the volume range? Yeah, they should do. It really, like, yes. I won't overcomplicate it. Is this helping? Not really too sure if it is, you know. I'm not sure this is helping actually. Okay, so on the side that's failed, we have the TIP 35Cs that have died. There we go. That's fine. The power supply MOSFETs are fine, so we don't need to pull it off of those. We just needed to get it off of the outputs there. Now we also want to take the board out of the case, so we need a screwdriver for that. And was that the only screw? Is there another one? I think that might be the only screw. So we still have something that is holding this down, but it's likely to be the transistors themselves. They kind of get a bit stuck to this thermal pad. So let's just grab some pliers and just give them a little wiggle. Yep, there we go. That one was stuck. As was that one. As was that one. Here we go. Now they're coming off. There we are. Oh, and there is actually one screw hiding underneath the crossover board. Okay, that should now come out. Ta-da! We have, yeah, that's just stuck on there. Cool. All right, let's pop that down to one side. Okay, so we need to go ahead and remove the TIP 35C and 36C, even though they're likely fine. One test you can do with Class AB is often, if it's not failed too dramatically, there'll actually only be one transistor that's failed on the bad side. And what you can do is you can cut out the bad transistor and power it up to see whether there's any drive circuit damage. So we can try and see which of these is likely to be the one that is toasted. Because they're all in parallel, they will all show a short. So we've got 2 ohms on that one. Let's see what one. 2 ohms on that one. 2 ohms on that one. 2 ohms on that one. So they're all paralleled so much that it's going to be quite hard, I think, to tell which one's dead. It could obviously also be that they are all dead to the same amount. Okay, so let's remove them and see if they are all toasted. USMC for Life says, I always get intimidated by working with 110 volt power products. Dude, imagine living in the UK, instead of them being 110 volts powered, they're 240 volts powered. It's scary shiz, bro. So a little bit of fresh solder on these pads, just to make them easier to come out. Other than vibration damage, are there any other components, I think that's supposed to say, that degrade over time/use? So capacitors will inherently degrade. They have liquid inside of them that will either dry up or, yeah, capacitors do have a cycle limit and an age limit. Typically though, car audio amplifiers aren't usually used for long enough for that to really ever be an issue. Unless you get some really old school stuff, but honestly, people don't keep their car audio system for that long that the capacitors are gonna dry up and you know, cause issues. But it depends if you've got like some really old stuff that you use like in your daily for like 15 years, or you've got some old amps sitting in the loft or something. Then yeah, absolutely. But generally, the capacitors will be fine. Yeah, transistors, semiconductor components, they do wear out, especially when driven hard. So yeah, if you've got an amplifier that you're driving hard, for many years, then yeah, they can degrade. The silicon structure can change inside of the transistors, and it's the reason that that happens is more to do with heat and cool cycles. So electronics hate heat cool cycles. So if you've got semiconductor silicon parts that are getting super hot and then getting super cold, then getting hot, then cold, then hot, then cold, that over time damages the internal structures of these parts and then they can fail, yes. That's 2 out of 4 removed. What's up, Anibal? Anibal Lopez, how's it going? Have you ever accidentally taken out the wrong FETs? Oh man, yeah, like, you do this thing as a job, like, everything's going to happen one time. I've accidentally taken out the wrong side of transistors. I'm just checking I haven't done that this time. I've accidentally put the wrong parts back in to what I placed, but noticed before I powered it up. What else have I done? Like, yeah, if you're working with this stuff every single day, then you're only human. You're going to make some mistakes. Going to make some silly mistakes. David says, I was a radar tech. They had 280,000 high voltage supplies. Wow. Yep, screw that shears. Why not disconnect the emitter resistors? Because I want to get them fully out of circuit. And also, if they are shorted, then they could be sending the some rail back down to the drive circuit, or having them present could cause other drive circuit issues that might look like there's more problems than there is. Better just to take them out. Start working on the amp while still powered. You laugh, right? But someone actually did. I was messaging someone helping them with an amplifier repair, and they were actually soldering and desoldering components while the bloody thing was powered up. Not even joking. I thought it was a joke at first, but no, they were actually soldering in MOSFETs while the amp was powered up. I was like, dude, don't do that. The worst kind of mistake to make, Seth, actually, yeah. So as an amp tech or anyone repairing something, especially if you're a mechanic as well, the worst one is when you spend like 4 or 5 hours taking parts out, replacing stuff, troubleshooting stuff, and like you might end up having taken out, desoldered, and replaced like over 50% of the components in this section of board that you're working on, only to find that maybe there was never an issue with it in the first place, and something very, very simple was wrong, or there was something that you didn't realize needed to happen in order for this circuit to start working, and there was no failed components in the first place. Something ridiculous like that, because it hurts, man. The realization of how much time you've just wasted on something that was fine, or that you just overlooked, is painful. Do you have a stream schedule? No, I don't, unfortunately. I just start streaming as and when the opportunity arises. It's very hard. I don't really have a very structured daily routine, very structured lifestyle. So yeah, I don't think a stream schedule would really work. I just kind of jump on as and when. How many cats do you have? 0 cats. I have 0 cats. So, are all of these transistors shorted, or was it just the one? Okay, that one's fine. That one's fine. Well, we don't know it's fine, but it's not shorted. That one's toasted. Bye-bye. And this one's not shorted. So we've got 3 here that are not shorted. As to whether they're fine or not, we can't tell that just from doing a quick test on the multimeter. What we can do though is we can shove it into our MK328, and that will tell us a bit more about these parts. So that is an NPN with a current gain of 71.5. Also, these parts are slightly warm because I just desoldered them, which will skew the readings slightly. So as long as they're not reading something ridiculous, then it should be fine. Okay, now this one is an NPN with a current gain of 446. So these are both the same parts. One of them is reading 70, one of them is reading 446. So we know that for sure at least one of those there is damaged. We just need to get a reference reading from one that is not damaged to know which one is damaged. Regardless, we're going to replace all of them anyway, but it's just interesting, isn't it? This one has a current gain of 58.6. So if I was to take a guess, I would say that the one with the current gain of over 400 is the one that is bad. Even though it still reads as an NPN transistor, it checks out okay on the multimeter and would probably power up in the circuit. This ain't going to last long. Okay, cool. So we have one channel down. The PNP transistors on this board for this channel are fine. However, it would be good practice to replace them anyway. Seeing as we're replacing the NPNs, we should also replace the PNPs so that we get new parts that are well matched in specification, because these parts will be pretty old now, tolerances might have changed and so on. So, but I don't think I have 4 of these transistors each in my parts bin, unfortunately. Let's have a look what we've got. 36, so I need 35s, don't I? I think it was 35s. Yeah, I need 35s. Yeah, so we're gonna have to buy some new parts. That's fine. Let's take our butts over to Farnell and RS and have a look. UK.RS. Now we don't absolutely have to use TIP 35C and 36C. It's what Kicker used in this amplifier. There's plenty of other transistors that would also work absolutely fine in here. But if we're going to have to buy new parts anyway, it would be cool to keep them the same as what was originally fitted. So let's see. TIP 35C. I don't particularly want to buy 30 of them. I would like to buy 4 of those, please. And while we're here, we're also going to buy 5, because they come in a pack of 5 of the 36C. So that's from RS Components and from Farnell. See if they're any cheaper here. TIP 35C. What's the difference between these two listings? Is this not the same component? Different manufacturer, okay. So we've got TIP 35C, 2 there from different manufacturers. So let's see what 36C is in stock and match it up. So I'm just open both of those in a new tab and then search for 36. Looks like we have another 2 here. Looks like we have 3 here. There's a... Oh no, that's no longer stocked. Okay, cool. So, right, these ones are not in stock. This brand here, whatever this one is, that is the ST branded one. So that is ST Microelectronics. So we're not going to buy from ST Microelectronics. We're going to buy the Multicomp Pro ones because we have stock of both the 35 and the 36. Come on. Are you going to work? What? Alright, how much is it from RS? Do I have an internet problem? The stream's still working. Seth, man, thanks for the 10. Holy crap. I'm trying to help you get the wide band I left you a DM on Facebook. Read it when you get a chance. Says, thank you so much, my friend. That's the SPL Lab sensor for my new series on 3D printed sub enclosures. Do you use DigiKey? Sometimes, but they usually ship from the States, so it's very expensive. It depends what the component is. Some DigiKey stuff is stocked in the UK and there's no shipping on it, but okay. Let's go back to screen. And has this loaded yet? Yes, it has. Okay, so just a little bit of a connection problem there. So let's add, what is it, 4 of those and also 4 of these. Go to my basket. Let's log in here. Get myself logged in so that we can see how much these are actually going to cost. Okay, so in my Farnell basket, I have a few bits already. I've got these relays for a project. I'm just going to go ahead and remove those for now. So we have some MOSFETs that I actually don't need anymore either. So we have 4 of the 35s and 4 of the 36s. That is going to cost... Wow, this is freaking expensive, man. Parts have gone absolutely through the roof, haven't they? I need 8 transistors and I'm looking at 40 quid. Absolutely ridiculous. A bit cheaper on RS, and we're actually going to get 1 extra because we're going to get 5 of these from RS, so we're going to have to go with RS. So I'm going to build up an order, keep that there for now, see what other parts we need in the future. Delivery as well. Okay, so let's continue with the repair. So because we need some new parts and we have some transistors here that are possibly fine. Like we say, we read the values on the transistor tester. Got some low values here on the 35s. A couple of these ones here were reading 70 and 50, I think it was. So I'm going to go with the lowest current gain transistor. I'm going to drop it back in the board. And that will allow us to power the amplifier up and check the health status of the drive circuit for the NPN side of this channel, just to make sure that there's no DC offset on the speaker terminals when this is powered up. Make sure that there's no excessive current draw from the power supply, and make sure the rest of the amplifier is functioning as intended. Then, if it is, we know that we just need to fit the new transistors when they arrive. Let's just get this solder off here and shove it back through one of the holes. There you go, just a quick tag on there to get it stuck in place so we can power it up. So if you're wondering about fitting just one transistor or one MOSFET to a bank of parallel transistors or MOSFETs in an amplifier, with Class AB, yes, no problems at all. You can fit just one transistor to a bank of 4, 8, 10 with no weird effects or damage issues or anything like that. To test it out, test out the channel is working fine. However, with Class D, you have to be a bit more careful. The reason you have to be more careful with Class D is that the drive circuit for any given Class D amplifier will be designed and optimized for a specific amount of gate charge from that bank and input capacitance from that bank. When you parallel many MOSFETs together, all of their gate charges and all of their input capacitances and stuff all add up for that bank, and the drive circuit will be optimized for the full number of FETs that are fitted. If you only fit one MOSFET to a bank that would otherwise have 6 MOSFETs, then you now have a sixth of the gate charge and input capacitance, and the drive circuit may not be very well versed at driving just that one MOSFET. It might be kind of, I don't want to say overdriving, but basically it can cause some problems, and I have actually experienced that myself with big Korean amplifiers from sort of 5K and upwards, where you've got a bank of MOSFETs that would usually have 4 or 5 24N40F MOSFETs in a bank. If you fit just one per bank and you turn the amplifier on, if you keep the voltage on the power supply between 9 and 10 volts, usually it's fine. You can idle the amplifier for 5 to 10 seconds, check that there's good class D switching on the MOSFETs that you've got fitted, and everything's fine. However, if you then try and turn the voltage up beyond 12 volts, start going 12, 13, 14, etc., I think that there ends up being some ringing or something occurring on the gate line to that one MOSFET, and because the drive circuit is optimized for the gate charge and input capacitance for 4 or 5 MOSFETs, when the voltage starts increasing and the ringing gets stronger, the voltages get higher, the MOSFETs just spontaneously explode. I've repeated that. I've managed to repeat that experiment a number of times, and the single MOSFET will fail in the bank, but then when you replace the single MOSFET with 4 instead, the amplifier works absolutely fine and doesn't explode even at 14 volts. So okay, let's flip her over and I guess we can power it up now and see if there's any drive circuit damage. Let's get some power wires in here. We have 12 volts on this side. New viewer from Canada. I really enjoy the content. Never really seen you give a personalized statement to the type of amplifiers that, let's say, are more quality driven. There's so many to choose from, and also the brands we get over here in the UK aren't the same as what you might have in other countries, so it's always a bit difficult for me to give recommendations for stuff, especially when a lot of my viewer base is in America and I don't really get to see a lot of the brands you have over there. Kabaz says, I want to buy a Preamp Smart 3. I don't know what's the difference between the regular Smart and the base model. Is it the same as on the Smart 5? Yes, pretty much. Although the issues that I suggested might be a problem with the Smart 5 differences are, I don't think they're really there on the Smart 3. So as to which one to buy the regular Smart 3 if your impedance is 1 ohm or 2 ohm. Buy the Smart 3 base if your impedance is 0.5 ohm. Simple as that. Another reason to buy the is that a solder bridge that someone's made? You know what, I think it is. I was having a look at this board here, and remember earlier on in the stream I said, hey, looks like somebody's tried to resolder something over here. Oh my god, they've made a freaking mess of this. So this is kind of burnt here. We've got this transistor here, which looks like actually has a solder bridge across legs 1 and 2, and also there's a great big hole in the relay where the soldering iron was hot and melted through the relay. Nice. Okay, let's clean that up. Definitely don't want to power it up with it looking like that, do we? I wonder if that transistor's actually dead, because if that was powered up while it was shorted like that, that might have caused some damage elsewhere. Okay, a bit of flux on those legs has got rid of the bridge, I think. Yep, it has. Let's just get rid of some of this excess solder that's on these legs here. Okay, good, good. Now let's test that transistor. Is it dead? Ooh, a 147. I'm not really keen on that. I know you do sometimes get low resistances between legs 1 and 3, but that's usually of the outputs, not of a transistor that is doing auxiliary voltage supply. What we could do is we could have a look at the TIP41C over the other side. So these will be doing auxiliary supply, probably plus minus 15 volts. So if we've got sort of 150 across, oh we do, okay, 147. So that's normal then for this amplifier. So one of these transistors will be doing plus 15, one of them will be doing minus 15. So that's probably fine, probably just a bad bodge on these legs here. I wonder if it's worth taking this transistor out though and seeing whether these legs are damaged, although it is really stiff in there, so I think that's probably fine. But yeah, not ideal. Okay, I think we're pretty safe to power it up now. But that's sorted. Got some power wires in, yeah, that's all fine. Just do a double brush check underneath here to make sure there's no solder underneath there. Okay, cool. Let's give it a zoom out. Okay, let's hit the power supply. Start off with about 10 volts, I think. There we go. 10 volts to start with, nice and low, just to keep the rail voltage a bit low in case there is a problem. And what we're going to do is we're going to probe the output of this transistor. So these should have rail voltage on, I have to remember which way around this is. I think you get rail voltage on pins 1 and 3, and then the output of the transistor is on pin 2, if I remember rightly. It's been a while since I've done a Class AB. Now, because this is Class AB, the biasing circuit will detect the temperature of the heatsink and adjust the bias for that. However, when the Class AB amplifier is not in the heatsink, then the heat that these transistors generate is not picked up by this transistor here that's to adjust the bias for heat. So therefore you can get a situation where a Class AB amplifier will go into thermal runaway when not in the heatsink. So when you're working on a Class AB amplifier and it's outside of the heatsink like this, don't leave it powered up for any more than like 5 or 10 seconds, because the output transistors will likely start getting hotter, and as they get hotter their resistance increases and they get even hotter, and the bias gets thrown out and they get even hotter and hotter and hotter until one of them's at like 200 degrees and it explodes. So yeah, very short amount of power on time when it's out of the heatsink like this. I need to get myself a new oscilloscope probe as well, because this one has a bit of inherent bad ground connection to the main scope. All right. Okay, we are powered up. 2.4 amps worth of idle current draw. There was a bit of noise on that pin there of that transistor. Now, I don't know if that's just because, obviously, I don't run a ground probe on my, a ground wire on my probe. The oscilloscope is just connected to the amplifier through the main ground. So if the output side ground is floated or has a high resistance, then we may see some noise on the scope. That's completely normal. Let's check it compared to the other side. You know what, this probe I'm actually not that keen on. One thing that I definitely need to get in my shopping list is a new set of multimeter probes and definitely a new set of scope probes. Okay, so if you were keen-eyed, you will have seen there that on the power supply up here, if I can point at it, you see the power supply up here started at 2.4 amps and then it increased gradually until it got to about 4 amps, where I have the power supply limit the current, and then I shut the amplifier off. So that is the current runaway, the kind of current runaway of these amplifiers probably occurring. Although nothing seemed to be getting crazy hot. Power supply FET's getting hot? Nope. Okay. So one way to check whether you are seeing weird stuff on your scope because it's not grounded correctly is to probe the negative speaker terminal. And that will tell you, you should see nothing on this. If you see weird stuff on the negative speaker terminal, just means your oscilloscope isn't grounded properly. Yep, there we go. So my oscilloscope just needs to be grounded to the output side ground. So let's take a ground probe, which I should have somewhere in here. There we go. Clip that onto my probe. Crocodile clip that onto the speaker negative terminal here. And now we should see a much cleaner view on the scope. There we go. Now we're actually seeing the rail voltage, which we weren't able to see before. I think actually on this one, it looks like we have rail voltage on pins 2. And pins 1 and 3 have the audio wave. Okay, cool. So it looks like we have positive rail over here. Negative rail over here, positive rail over here, negative rail over here, and then we shouldn't have any voltage on pin 1 or 3 over here. Nope, no DC voltage on either of those. That's really good to see. So let's let the amplifier power up fully and make sure there's no DC offset on here. Nope, that looks fine. You can see the current is starting to rise, so we're going to turn the amplifier off. But that's good. Just wanted to make sure we didn't have any DC offset on that bad channel. So now the next thing to do is to plug in an RCA, shove it into the input of the amplifier here, and just make sure that the sine wave output is nice and clean. Just change the scope settings here to view a sine wave cleanly. Reject high frequency, 5 milliseconds. Turn the signal generator on. And adjust the gain on the side of the amplifier. Get it turned down a bit. RP502, holy crap man, thanks so much for the 20. Probe test lead funds, my man, thank you so much my friend. I'll be ordering some of those this evening. You didn't need to do that. Thank you though. Super interesting videos that you do. After watching Steve Mead and Wilson Audio, nice to see someone local to the UK. I appreciate that. Yeah, don't think there's that many people in the UK doing car audio YouTube stuff. So yeah, I'm your local Brit over here. Friendly local Brit. Love to see funding for Sam. Thanks. Yeah, thank you so much, RP502. That was unexpected. You didn't need to do that. Hi, Jack. How's it going? Just popped in to say hi. Can't stick around much. No worries, man. I appreciate you dropping in and letting me know that you're here. I connected the amp to head unit. Big sparks came from the RCA inputs. Oh shit, that's not a good thing. They were connected to a PC power supply. Each of them works perfectly until I connected them together with an RCA cable. Head unit works, but RCA output doesn't. Sub-amp did not work. I changed blown resistor in the power supply area and it now turns on, but volume is low and slightly distorted. Too many issues. Unfortunately, I won't be able to diagnose that over chat, Gabriel. Sounds like you had a massive DC, massive ground offset, ground potential difference between your amplifier and your head unit, and that could either be a faulty amplifier, could either be the way that the head unit amplifier were connected. Running car audio indoors is a recipe for disaster. I know lots of people have done it, I've done it in the past, but if you want audio indoors, buy mains powered amplifiers, mains powered preamps, equipment, receivers, stuff designed to run off the wall. It's really inefficient, really stupid using car audio equipment permanently indoors as a setup. It's not worth doing, and you will run into either issues or you won't get the best performance that you could otherwise be getting from similarly priced home stuff. Thanks to something beast. Thanks very much for the 20 bucks. Holy crap, you guys are nuts this evening. Appreciate you guys. Thank you so much. Okay, so we're checking for a nice clean sine wave now on the output side of this amplifier. So let's just power it up. We've got 313 hertz going in. So pin 3 is going to be the output here for the channel. So let's power up and have a look, see what we got. I need to do this quick before the current runs away. I don't see anything on the scope. I have low pass, don't I? I have low pass enabled, so I need to change the frequency to about 35 hertz. Got 38 hertz now, maybe that's why. Oh, I'll probably have the RCA in the wrong hole as well. I'll probably have it in the channel over this side. Let's just check the channel over this side. Okay, not getting anything over there either. Okay, now that's interesting. So we've got a signal definitely going in. Just to confirm, I've got a signal on the RCA. Zoom out a bit. So there is signal on the RCA here. That's fine. We've got that going into amplifier input. We're going to go for amplifier input left. We have, oh, of course, silly me. This is not connected to the amplifier, so we don't have continuity through the preamp board. So let's shove that back in. That should now be fine. And just double check, the channel that we are looking for clean audio on, which was the blown channel, is this one. So that is not going to be connected to the speaker terminals because of the relay, so we're just going to have to guess. Okie doke. So still not getting any audio. There's a very, very faint bit of audio on this pin over here. So I suspect that we have a preamplifier issue, and that might be something to do with the fact that this transistor down here had a solder bridge when this amplifier came in. So these transistors, like I said earlier, will be generating plus minus 15 volts auxiliary for the preamplifier circuit. Now if that leg was shorted, was due to a solder bridge, not sure, someone decided to try and solder that on for some reason, we might have damaged op amps in the preamplifier section, or we might have a damaged transistor over here, therefore we're not generating plus minus 15 volts. So if there's a case where you're not getting any audio from an amplifier that otherwise seems fine, easy test to do is just to hone in on the preamplifier circuit and measure that you have 15 plus minus there or thereabouts on the op amps. Fortunately for us, Kicker has been kind enough to give us some headers here, some pins to actually test these voltages on. So all we need to do is attach our ground probe again that has currently fallen off. Yep, and all we need to do is just probe these pins here and see whether we have the correct voltages on them. So plus minus 45 volts is going to be our rails, so let's just double check that we have those. Yep, 42 there, and there's our negative rail, that's fine. So now let's see if we have plus minus 15. Okay, there's our plus 15. And there's our negative 15, so we do have plus and minus 15. Now these middle ones, they're marked U5 to 6 and U2 to 6. Not sure what those mean. Let's see what's on them. I think that's some kind of feedback, because that is mimicking what I saw a moment ago on the output pin of those transistors. So I would say that's some kind of feedback. Then we have left plus and right plus. So provided the preamplifier circuit is working, we should see some signal on these pins coming from the preamplifier section. So we've got 38 Hertz. I have the RCA connected to the right hand input, which is this one. Okay, there's not really any sine wave on there. I have the signal turned up quite a bit. So what I'm going to do now is I'm going to play around with the gain potentiometer. It's possible that the gain potentiometer is a bit damaged, a bit dirty inside. So I'm going to switch the gain potentiometer around while I'm probing this, see if we get a good signal or not. No, but we do get some DC. I think that we have a preamplifier fault as well. So let's take another look at that. If you just missed that, I'm going to see if I can just clip my probe on so I don't have to hold it there. It's getting a bit of a pain in the arse. That's got something stuck in it, that one. Another 10 from Seth, dude. Chill out, man. Holy crap, thank you, dude. Check the switches on the X-Over and all the other switches. This is an old AF amp and does strange things with dirty contacts. Yes, absolutely. That's definitely something we're going to check. So right hand signal side, I'm going to power the amplifier up again and watch what we get on there as I spin the gain potentiometer. So as I'm spinning the gain, you can see here that we've got a bit of DC there coming in and out of the signal line. Let's put this probe onto our left input here and double check that one as well. Okay, same thing. So first thing that I would do in this case is take a look at this board, which is the one that Seth suggested just now, and give this switch on here, which is the low pass, high pass, bypass switch, a good old clean with some isopropyl alcohol. Because the contacts in here get oxidized and prevent signal from passing through the switch, which is one of the most common reasons for no audio on old amps like this. Yo, look at you guys! You guys are freaking insane this evening. My screen is just full of colourful cubes of... Dude! Holy shit. My guys, thank you so much, but chill, it's cool. I do this for free. Thank you so much, holy shit. Rob, with our 50 bucks, since we're trying to help with the new channel, this may help you with your landline phone. Man knows about the landline phone. I always love it when people mention the landline phone. It means that you were there with me during Streamus 2020, I think it was 2020, 2019? A couple of years ago. That was good times. Thanks, Rob. I really appreciate that. 50 bucks is a lot of money to just throw at someone on the internet, so appreciate that. And also, Kubaz, sorry if I'm saying your user wrong. Thanks for the 20 PLN. Thanks, your videos are always so helpful. Man, I really appreciate you guys. Thank you very much. I do this because it's fun, and hopefully someone gets some use out of it. But it's really, really nice to see you guys are appreciating the content. Turklo says, Sam, check out Kawit for your test probes. They have some... Ow! Whew! You know when you spray that isopropyl alcohol, it shows up every tiny little cut that you didn't know you had on your hand. Yep, somehow managed to slice my finger there. Now another 10 from Seth. Pretty sure we want to help. Fucking hell, man. Thank you very much, Seth. Chill, man. They have some a nice assortment and kits. I use them and they're really good and affordable. Thanks, Turklo. I'll definitely check them out. Hopefully they're available in the UK. I also decided to clean up the contacts here as well. They look like they had a bit of black stuff on them, so they may have been preventing signal from passing. So let's shove that back in and test again. See if we get any audio this time. So we are RCA into the right-hand channel. Let's clip it on and look for sine waves. Wait, did I put that back into... Let's put it onto bypass. I'm going to bypass the crossover just so we've got a full range signal going through. I think my ground probe unclipped itself then for a moment. Let's clip that back on. Oh, okay. Now we have something, although it doesn't... It's not looking the best. We definitely have a sine wave there now. So that was one of the problems with this amplifier, was dirty switches and dirty contacts. So I'm going to turn the gain down to minimum just now, and I'm going to slowly increase it a bit. Okay. This is a massive sine wave. I think this might actually be feedback. We've got like a massive amplitude sine wave that can't be coming from the preamp. That must be feedback from the output side. Left plus and right minus, yeah, that must be. Okay, well let's attach our probe over here instead onto the transistor itself, and see if we have audio over there as well. Might be a good idea to clean this gain potentiometer. Okay, so yes, we have audio now. Looks like it takes a minute for it to kick in. We have current runaway due to overheating parts, so let's just wait for these parts to cool down a minute. So yeah, just while we're waiting for these transistors to cool down, you can spray some isopropyl alcohol on them as well. It helps them cool down a bit quicker. We're going to spray some isopropyl as well onto the gain potentiometer because that seems to be a little bit noisy and scratchy. So spray that in there, get that nicely into the contacts of the potentiometers there. Okay, cool, that's good. Shove that back into there. I imagine what I would hope that when we switch this to bypass, sorry, when we switch this to low pass, it clones the input from the RCAs to both channels. I would hope it does that because low pass you'd only ever really be using a subwoofer, so it'd be nice if it cloned the RCA inputs between both channels. Okay, let's power it on again. So, okay, looks like we have to give it a fair bit of signal. Okay. I actually reckon that these relays are on their way out as well, and they're doing a similar thing to my Technics amp. Oh, because that wouldn't affect, no, that wouldn't affect the signal going to the... Oh, that does not look healthy. Look at this. Look, I'm going to give you the scope screen right now. This could either be a dodgy gain potentiometer or a drive circuit fault or something. So look at the shape of that sine wave. That is not pretty. That has a bunch of nonsense on it. So is that preamp related? Let's put it onto bypass. I'm going to take this thing out again, switch it to bypass and see if that crap is still there. Got too much current going. You know what I'm going to do? Actually, to alleviate the current runaway, okay, so I can actually get this amplifier powered on and stayed powered on for longer, I'm going to actually turn the bias on both channels all the way to minimum. That should allow this whole thing to run really, really cool. So all the way down to minimum on you, and you're underneath her there, all the way down to minimum on you. So now the idle current draw should be very low and it shouldn't go into thermal runaway. There we go. So now we've gone down to 1.3 amps worth of idle current draw and it's not increasing. See that? 1.3 is staying constant. We're not going into thermal runaway because we have taken the bias out of the overlap point, so these transistors are not coming on together anymore. We'll need to obviously reset the bias when it comes to it once this is repaired, but for now this allows us to work on this amplifier safely without risking overheating the transistors. Okay. Woo! Oh yeah, okay, so because we've turned the bias down, we get a lot of crap happen when the sine wave comes on, so we need to keep the sine wave nice and low amplitude for these tests. So we get nice clean audio now, but it seems that it needs to be kick-started a little bit. See, when we first turn the amplifier on, so it's powered up just now, there's no audio output yet. I have to just nudge the gain a little bit, and then only when it gets to a certain point does the audio suddenly appear. Now that might be a feature, but it seems to me like a bug. I don't think that should be the case. Let's check the other channel. Let's check the right hand channel and see if that's the same. So I've clipped it over to the right hand channel now. Let's see if that's the same. Nope, it's even worse. Look at what the right hand channel's doing. Okay. So, most certainly some preamp fault. I would assume that there is some preamp fault here. Alright, let's take our oscilloscope probe and let's move it over to the preamp side. And let's have a look at what we've got going on over here on the op amps on the preamp side. If there's any DC voltage on any of the op amps where there shouldn't be, aka anywhere that's not a VCC pin, then we know we have dead op amp. and that could be causing some of these issues. So let's power her up, and let's see what we've got going on the op amps over here. So, pin 1 of this TL072C. Let's zoom in a bit more on the scope. There we go. 5 volts divide, 2 milliseconds, that's fine. Okay, so we've got a sine wave. Oh no, we've got... okay, so there's no DC on pin 1, but we do have a sine wave, so that's fine. Pin 2, sine wave. Pin 3, sine wave. Okie dokie. That looks fine. Then we've got our supply voltage on pin 4. Pin 5, we have nothing. Pin 6, nothing. Pin 7, sine wave, and pin 8, supply voltage. So that one's fine. This op amp over here, we have nothing pin 1, nothing pin 2, pin 3. Oh, pin 3 has some jumpy stuff. Okay, look at this. Okay, look at this on the scope. Hopefully I can show you it, and it will come out nicely. So you see we've got this little bump every now and then on pin 3 of this op amp. And that seems to be corresponding to a little bump that we get on the output of the right hand side channel. You see that little bump that we're getting there on the right hand side channel? That seems to be being amplified by the output section. So it's possible that this op amp could be bad, or one of the components around it. Okay, pin 4 is just our supply voltage, that's fine. Let's make sure that doesn't have any bumps on it or anything. Yep, that looks fine. Okay, pin number 5, we have nothing. Pin number 6, we have nothing. Pin number 7, nothing, and pin number 8, supply voltage. So it's possible that this 072C might be a little faulty. We're getting some bumps and pulses on pin 3. Let's go and have a look at where pin 3 goes. You can see it goes to this little capacitor here, C2. So let's see what's on the other side of that capacitor. So we should have the little bumps that we saw a minute ago on this side of the capacitor. Yep, there's one. So let's have a look at the other side of the capacitor. Not sure if I'm seeing them on the other side. Not seeing them on pin 3 anymore either. We're also not seeing them on the output transistor anymore either, I don't think. That's interesting. So that seems to have stopped doing that, and I wonder whether that's because I touched the capacitor. See, these little surface mount caps, especially with age, they can go faulty, and just as much as even touching them can actually cause whatever issues they have to get resolved. So there's a sine wave on this top 072C on that capacitor. So if I flip the RCA around now, no, we should be getting a sine wave, I think, on that one. Yeah, okay, so the RCA inputs are actually cloned. So we should get the same, even though this is on bypass, we should get the same output on both RCAs, it would seem. So this is currently plugged into the right-hand RCA. And if we have a look at the right-hand side speaker terminal, we have that. If we go into the left side, Okay, so the left side, we don't get any audio at all. Let's have a probe of the gain potentiometer and see whether the gain potentiometer is dirty, which should be causing that. If we turn the gain potentiometer up, that doesn't resolve our issue. We're still not getting any audio, really, a tiny little bit, but barely anything on the left-hand channel, and that's the channel that didn't have any dead transistors. So I'm willing to say that is a preamplifier issue. Might just need to clean the switches on that on this board a little bit more, actually. I'm going to flick it from bypass into high pass. We haven't tried high pass mode yet, so I just want to see if high pass mode gives us any audio. So I'm going to go up to about 500 hertz. No, let's go up to about a kilohertz, 1000 hertz. About 1000 hertz we've got going in now. Just reduce to 735 hertz we've got going in now. So this is now on high pass mode. So let's see whether we get sine waves on left hand channel. Nope. I'm going to increase the bias a little bit because the bias being so low I think is causing some issues with when we apply a signal. So let's increase the bias just a touch. No, still issues. So I think on this amplifier, when you apply a signal with audio signal through it with the bias not set correctly, you get a bunch of high frequency noise. I have seen that on Class AB amplifiers before. It just means it's a little bit more difficult to troubleshoot here. But yeah, we're not seeing any audio on the left hand channel over here. So we're back down at 30 hertz now. Now we're not getting anything. Oh, you know what? As I touch and move this, getting a lot of noise going on. There's a lot of DC stuff going on as I move this. Whoa! Okay, so there's definitely an issue with the connection there from this crossover board. As I sort of move it around, it causes all kinds of weird stuff to go on the main board. So one of the things I'm going to do first is I'm going to refresh the solder connections from this little upright board on the board here to the main board. You can see here how it's connected, just kind of with the solder blobs on this side, and also on the bottom. So I'm going to refresh all of these solder connections. Even though they look fine, they can be bad, especially with a bit of board flex that this thing's definitely been subjected to. So I'm going to go ahead and reflow those connections first. Then I'm going to spray some isopropyl alcohol into this connector here and go from there and test again. Thanks to Sif for the 20 from Denmark. Thank you very much, my friend. Really, really appreciate that. Is that molten relay okay? Yeah, the relays wouldn't be causing this issue, so we're going to fix whatever this issue is first, and then make sure that there's audio on the terminals, and if there's not, then we can maybe replace the relay. But the relay, the plastic just looks a bit melted from where someone had a soldering iron up against it. I don't think it's going to have affected any of the internals. Okay. This is such a janky way to connect a daughter board to a main board. I see so many amplifiers with this style of connector where, yeah, there's just cracked solder joints on these things. Really janky. Okay, so that's those reflowed. Now we need to spray some isopropyl into this connector here. And in order to get that cleaned up, I'm going to spray it on this as well and shove it in and out there just to clean these contacts up a bit. Okay. So let's do another power on test, just see whether that has changed anything. See whether that's improved, worsened. Mickey, yo, thank you so much for the 10, my man. Thank you very much for the 10, Mickey. I'll have you know, I graduated top of my class in the Navy cosmetology, and I've been involved in numerous secret raids at Maybelline, and I have over 300 confirmed dermatologist appointments. Thanks for the information. Thanks for the 10. Okay, cool. Let's give this a go then. Get the ground probe connected back up. We have 31 Hertz going in. Just double check that that definitely is 31 Hertz. Yep, definitely 31 Hertz. Let's go into the left. Okay, so let's probe this channel first. See what we got. Don't seem to get anything on that one. Over here, don't seem to be getting anything over on that one either. Are there any switches or anything on the actual amplifier itself, or is it just all on that board? Whoa, okay, so it's still, when I touch this, we get big spikes. I'm wondering whether there's actually bad soldered connections on this little daughter board itself. Let's have a look at this board itself in detail here. So it's when I twist it, twist this board slightly. There's not much going on here really. These traces all look great. These components all look fine. Let's check the pins of these op amps. It would actually also be really useful to probe these op amps when they're in circuit to see if there's any DC on any of these pins, these TL074s. Is there a way to bypass the crossover totally? Possibly, actually, Seth. Thanks again for the 10 again. What we can do is we could take the signal coming into this board here, and then just jump over to the pin where it's supposed to come out. We could do that. Yep, we could do that. Although one thing to do though would be to see whether we actually get good audio going into this board to start with. So yeah, that's not a bad shout, Seth. Thanks for that. Let's power it up and see whether we've got any audio going into this board in the first place. Well, I haven't even powered the amplifier up yet, and there's already a sine wave on one of these pins here. So this is with the amplifier powered off. So no sine waves on the 072Cs over here. So I would say that maybe the signal goes through this board first and then goes to the rest of the circuit. Let's have a look at the traces on the underside. Where does it take it from the RCA block? So the RCA block, we have connections here, and then we have a trace that goes over there. Yeah, it looks like, you know what, it looks like that the RCA signal actually goes to the low pass filter circuit, this thing first, before going to these op amps over here. Billy says you can jump the signal. Okay, thanks, Billy. I mean, this feels pretty tight, not gonna lie. We have a pretty strong connection there, by the feel of it at least. Maybe I can re-bend these pins a little bit. I mean, they're definitely all got some nice spring action on them still. They're definitely connecting nicely. Maybe if I reflow these pins on the back side here for the connector. I'm not sure if you can hear the sizzling noise coming through the stream, but I think that's isopropyl alcohol evaporating from the other side. Pretty cool to hear. Okay. Check the standoff, says Seth. So we've checked this, we've checked the solder connections here, and on the other side here, and on the back side. We've checked all of these pins here, all of the headers and the pins, connectors here, reflowed all of these, so that should be everything about this connection setup that has been covered now. Okay. So yeah, we clearly have input from the RCA there. The amplifier's not even turned on yet. and then the other input signal we have over there. Okay, so both signals are definitely making their way to this board. So let's power it up again and see what we got. I'm wondering whether it's this switch. I'm going to clean it again. What's up, Mike Honda? How's it going? See, now we've got something on here. Now we've got a bunch of noise here. I didn't change anything. All I did was just clean that switch. Ooh, what is that? What is that? That's in low pass mode. Let's put it onto bypass mode. Ooh. Okay, well, it's definitely something to do with that switch. Whether it is the, well, whether it's the 074Cs that are bad. Now we've got clean audio on this channel. There we go. So it's in bypass mode now. Got cleanish audio on that channel because the bias isn't set. Nothing on this channel though. So that's in bypass. So yeah, it's definitely something to do with this board. So it's either this switch is just really, really shit, where I think I've got one that would fit that. I think I've got a switch that would fit that pin configuration I could try changing, or it's the 074Cs on this board that are screwed. Unfortunately, because of the way that this mounts, I don't have access to the 074Cs to test them while this is in circuit because of how it mounts upside down. I can't actually get my oscilloscope probe to it while it's mounted. So we could just replace the 074Cs and hope for the best there. Yep, so, what the fuck? We have a square wave. Man, this amp is kicking out all kinds of stuff. I honestly think that that's a TL074C issue. I think that the switch is probably fine. It looks nice and clean. We've cleaned it lots with isopropyl alcohol. I suspect that it's probably the 074Cs that have had enough. So I'm going to try changing out the 074Cs, and if that doesn't help, then we'll do something with the switch. But I honestly think, especially since we had one of these VCC transistors over here jumped with a solder bridge, I think that probably one of the 074Cs is not having the best time. So let's see if I've got any spares of those and we can swap those out. I should have some spares 074Cs in here. Okay, let's see whether that makes any difference. Let's double check that they're the right type. I think there's a way to bypass that board totally. Yeah, maybe, but it'd be cool if we can actually fix it, you know. TL074, that's 074I, that's probably fine as well. TL074C. LM339, not that. Actually, you know what, there's some 074s on this donor board here. So I actually don't think I have two matched 074s that are brand new. So if we're going to take donored ones for now, or if this works, we'll replace them with new ones when we order some parts from Farnell in a minute. But I'm just going to grab a couple of 074s from this donor preamp card that came from a JBL. Now when you're heating up op amps, they're actually very sensitive to heat. I've found this out with 7.2Cs and LM211s when replacing drive board components on Koreans. So you have to be kind of careful not to overheat these. So serious, I think the amp is fixed. I think the amp is fine. We've seen clean-ish audio on both channels at varying different points. So it seems that this amplifier had one dead output transistor that didn't affect the drive circuit. So the amplifier, I suspect, is absolutely fine. But the issue here is with the preamplifier circuit. So that's what we're kind of sticking with. So I'm deliberately not putting my hot air gun over the chip directly, which you probably can't see. I'm just kind of putting it over the pins rather than the chip itself, because I don't want to overheat the silicon inside the chip. There's one. Hot air guns sound very funny. Does it? I'm not sure what it sounds like on stream. Okay, there we go, there's two. So let's take these original ones off of this card here. I want to try and avoid melting these capacitors next to it. Very easy to do when you're working in confined spaces like this. One thing you can do is you can get some aluminium foil and wrap the caps in the aluminium foil, which just prevents any heat getting to them. But I just kind of want to do this quickly. There we go, there's one. And the caps are in good shape still. There's not much thermal mass on this little board, so shouldn't really need to heat it for too long. Freshen up the solder on these pads. Okay, pads refreshed. Thanks, David, for the 20. My dude. Thank you very much. I really appreciate that, dude. We'll shove some fresh flux on here and then get these new 074s in. Okay, that should do. What temperature do I run the hot air gun? It doesn't really work like that because the temperature out of the hot air gun changes depending on how close or far you hold it from the components. So, but my machine says 400, but it doesn't really mean anything. Seth, another 5. I think my bank froze my card from sending you money. Unless you get this, I got it. Thanks, Seth. Man, you're crazy, dude. Y'all crazy. Don't apologize for sending me money. Right. Okay, am I right in my guess that the 074s were bad? Or is it just janky connections and shit like that? What's it going to be? Let's have a look. So, same signal going in. Probe this output. Woo. Okay, no, still the same shit. Exactly the same shit. And yeah, it's messing around as I fiddle with this. It's like screwing around. Well, I've reflowed every solder joint that there was on there. I've checked the pin health, which is fine, so I'm not really too sure what else it could be. So without that card connected, everything comes on, no weird noises. Okay, that's off. With the card connected, I'm just kind of giving the main board a tap just to see whether it's anything on the main board that moves. Doesn't seem to be anything on the main board. Seems to just be on this crossover card. When we touch it, we get all the weirdness. Although not anymore for some reason. Now it's not giving me any weirdness, it's just staying on with no issues. Unless it's in protect. Do I think it's in protect? No, relay's clicked in. Okay, maybe I could try hard soldering this card to the board. What do you reckon about that? What do you reckon about hard soldering this card to the board? There's just one solder connection in there that just doesn't look that great. I'm just going to reflow it. We can do a continuity test to the main board. We could see what pin is not connecting properly, if there are any. Well, that is definitely every single pin reflowed twice. Okay. Oh wow, there's like absolute nonsense going on this channel now. What the heck? Let's check what we have on this switch, because if we've got DC on that switch, that's not going to be so good, is it? There's negative 13 volts on the switch. There's that signal that's going to the right hand channel. Those board connectors break traces where the solder ends. Always! Huh! Thomas CNC. Thanks for the heads up. Let's get the microscope out and let's have a look. And see whether that's the case here. That might be a viable way forward. I'm using Chip Quick Chip Chip Quick? Yeah, Chip Quick Flux. Much really, really good stuff. Massive square wave now. Just on the right hand channel though. Yeesh kebab. Okay. Okay. It did have a number on it, but I removed the label, so I can't remember. I'll have a look later. I have actually mentioned what flux I use in quite a lot of my live streams, so you could maybe look back, but I could check my emails in a bit. So Thomas CNC suggests that the traces to these pads may snap. So I've actually had this before where even though you can't see the traces snapped, that they have been snapped. So what I'm going to do is I'm going to desolder this entire thing. I'm going to scratch back a little bit of copper trace on each of these and then reflow all of them and see what that does. This might prove quite tricky to remove. I might need to get my big soldering iron out that has a lot of thermal mass to get this out. I could always use the sucker perhaps. I think this might take a little bit of wiggling to get out. Yeah, no, I think it's going to be easier to flood this and wiggle it out rather than trying to remove the solder. Okay, she's out. So what we're going to do first is we're going to scratch away at the traces leading to these pads and flow fresh solder up the traces in case they are snapped a little further up. So let's zoom in a bit on here. I mean, I guess it could also be this connector itself that's bad inside, but I don't know, somehow doubt it. Looks like a pretty nice industrial rugged connector, doesn't it? And we're also going to do the same on the main board as well. Okay. Actually, I'll do that when it comes around to soldering it back in. Okay. Now this isn't really going to go in the board anymore, is it? Because I've thickened these up with solder just now. Naturally. I should use my solder wick for this. Right, let's just make sure there's a bit of solder flowed on the scratched back traces that we made, just to bridge over any gaps that might be there. Yo! Screws first. Yeah, probably should have done screws first, my bad. Kind of got a bit lost in the moment there. So in regards to these ones on the actual thingy itself, I don't imagine that any of those are going to be bad, because they're not under any stress when you plug it in and take it out. Like, there's no bending stress going on these like there is on the ones on the main board. So I'm just going to leave those for now, just because I really doubt that they're going to be an issue. Let's go back in. Man, we just got a whole bunch of DC nonsense on this one. Look at that. It's like a heartbeat. Full rail and then back again. Full rail, then back again. He only does it. Actually, it's doing it all the time, regardless of whether we've got the RCA plugged in or not. So, yeah, I have no freaking idea. I'm kind of a bit bamboozled now. Got a bunch of DC and a bunch of nonsense on this switch. I reckon it might be the 074s, but they don't like being soldered and desoldered. Honestly, they don't like being heated and unheated. So maybe I'll buy some new 074s so that I don't have to desolder them, and then just like manually tack them onto the board with the soldering iron rather than using the heat gun. I've run into these issues before where preamp faults just seem to never go away because I'm soldering in the op amps with the hot air gun. Yeah, look, the issue changes. The issue changes when I switch the switch to a different crossover mode. So I honestly think that it's 074s. So I'm going to order some new 074s and I'm going to tap them in manually with the iron. Jesus Christ, man. When the hell was 074s a pound each? That's ridiculous. No, I don't want 2,500 of them. I don't want 90 of those. I guess I could go for 20 of those. That costs the same amount of money as 10 of the other ones. 074 CDT. I guess I can order 20 of those. Yep, I guess that's what we're doing. So, the issue is on this board. I think it's the 074Cs. This switch appears to be fine. It's cleaned and yeah, I don't think the switch is the issue. I think the issue is the 074Cs. I reckon the original 074Cs were bad and we replaced them with ones from a donor board, and in soldering, desoldering, soldering, we have made them be also bad because op amps don't like being heated. I have noticed this from repair experience. So I think we're going to order some new 074s and I'm just going to solder them in with the iron to prevent heating the op amp case and see if that makes any difference. I've managed to fix Class Ds like with the 072s and 211s that way when I've been struggling like this, so yeah. I think we'll, oh man, thanks Mickey for the 20, for the chips, man, you guys are too kind. Thank you so much, Mickey, I really appreciate you guys. You're ridiculous. Yeah, I really appreciate you guys jumping on and keeping me company for this repair. I was hoping to get through a few amps this evening, but it seems to be not the case. We'll pick up with, I don't know, maybe I'll just fix this one when the 074s come. Maybe I'll do it on a stream again. See how life goes. I've got some stuff to do next week. No, this week. I've got some stuff to do this week with my new video series, which is the miniature subwoofers, which is this little guy. Look at this. Look at this thing. Look at this thing. Look at this cute boy. This is one of the options I've got for the miniature 2-inch subwoofer box challenge series. You can see this one has a massive voice coil, not much in the way of spider. Relatively stiff, still moves a fair bit actually. I've got this one to its limits and it does move really nicely. The other option for driver is this one, which has a smaller voice coil, more spider, softer suspension here, but yeah. And I also have this one in a Neo version. I got both the Neo and the ferrite version of that woofer. See, this is the Neo version, this is the ferrite version, both the same woofer. Very similar specs. The ferrite version actually models slightly better in BB6. So I haven't decided which one I'm going to be using yet. It will probably be the Neo version of this one, just because it's much easier to get in and out of the enclosure. This one, the motor is pretty much the same width as the cutout diameter, and you can see how I 3D printed this test box, but I actually had to file away at the hole, which is why it looks rough, because it was just too small. The motor only literally just fits, and it's a bit of a squeeze at that. And then the speaker goes in like that. And then because the hole needs to be so big, there's quite you have to position this dead straight, because you can see there's the speaker hole there, so you have to dead center this to get rid of the hole, and I'd have to use some kind of foam or some kind of blue tack to seal this all the way around as well. So yeah, I'll probably end up using the Neo version, because it's just going to be much easier to mount in the enclosure like that. But I would like to use this one because it looks cool. So maybe I'll use this one because it looks cool, and the cutout diameter is much smaller on this one, and there's more material there for it to sit down on. So may end up just going with this one. Yeah, this actually has quite a lot of movement. Yeah, this has loads of movement. Even given the small spider on it. This one doesn't seem to bottom out. These ones have a bottom. They bottom out. I can't quite do it with my hand, but I think I did manage to hit the back plate on one of these when I was testing a while ago. So yeah, I think that Klipsch looking one has more mechanical excursion. That one, I get more resistance as I push in on that one, whereas this one I can go deeper. Oh yeah, this one's got way more excursion. Yeah, fuck it, I think I'll use this one. Yeah, we'll go with this one. That's that decided. I was struggling to decide which woofer to go for, but actually I think I've just decided on stream. Yeah, these ones have a bigger spider, but the roll deepness is way shallower. I don't think you can really see it in there. No, none of these cameras are going to really be able to show you in there. But yeah, the spider on this one's much bigger because it has a smaller coil, but this one is definitely moving loads. This one is moving a shit ton, so I think I'm going to go with this one. It looks cooler as well, doesn't it? So, yep. So yeah, guys, thanks for keeping me company. Sorry that we didn't manage to get this amp prepared. Just do be like that sometimes. I'm going to order some parts, and I'm going to work on some videos that I'm working on, Class AB versus Class D, first episode of the box series. So yeah, I need to crack on with some of that stuff. You guys have been absolutely wild this evening with donations. I can't thank you enough. Honestly, don't expect any of that at all. Just kind of do this for fun and to get some company while I'm in the workshop. So really, really do love you guys. Really appreciate all of your kindness there. So yeah, stay tuned to the channel, and I'll see you in the next one. Take it easy.